Okay, so I'm going to talk to you today a little bit about insecticide toxicity to bees and mosquitoes. And how many of you think that you're killing bees with your mosquito control treatments? Good, because it may be that you're not. And the thing is that when you look at the web and all that fake science that's out there right now, it's hard to differentiate what's real and fake, isn't it? And there's um, a lot of problems with people not understanding what you do and how well you do it from the standpoint of mosquito control. So when you go to the web, it's very interesting. The you, you need to tell me whether this is real or fake. Okay, we're going to play a little game and see whether you believe that this is real or fake. Kitten guilty of murder. I'm not exactly a cat lover, so that may be true, right? Do you think that's really real or fake? Yeah, I think that's fake. How about Hillary Clinton adopts an alien baby? That has to be true, right? How about Putin may have ties to Russia? Do you agree with that? Yeah, he probably runs Russia, doesn't he? He owns Russia right now. Unbelievable. How about wind power? Uses giant fans to make wind. Do you realize that there are people that actually believe that those fans are going around and creating wind as opposed to creating electricity from the wind? I never would have thought of that. There are people out there with tremendous imaginations. And of course, then what do you think about this? Mosquito spraying kills pollinators. That's what is signed by the side of the road.
I don't think they're getting any service.
You're not going to spray next to that sign, right? Yeah, so we took on with a Florida Department of Agriculture grant a couple of years ago whether that would be true or false, and try to figure out whether that was fake or whether that was genuine information. And you can look on the web and you can see things like if the bee disappears from the surface of the earth, man would have no more than 4 years to live, and they attribute that to Albert Einstein. Well, it turns out people that have investigated that have said that there's no good evidence that Albert Einstein ever said that. Do you realize that that's fake information that's out there that is not real? And as a matter of fact, global food production attributable to animal pollination, including bees, ranges from 5% in industrial nations or 8% in the developing world. That doesn't make any sense because everything that you hear is we would starve to death if bees were not around. As a matter of fact, the honeybee did not occur here in the United States till it was imported from Europe. So we have the Italian bees that were brought in and are an introduced species that are essential for certain parts of agriculture. And they are important pollinators if you want oranges, which is maybe a part of our agricultural crop here in Florida, going downhill rapidly. You realize it's only half the size of the industry that it was a few years ago. So that's going down. They say no bees, no apples, no kiwis if we have no bees. So apples, blueberries, onions, tomatoes, kiwis, cranberries, melons, and everybody loves broccoli. You would have no more broccoli if we didn't have bees. So it's unbelievable that, yeah, those crops are the ones that are needed, but there are a wide variety of crops that are wind pollinated and not insect pollinated. So when you start looking at it, the things that we rely on for people to live, which are the grain crops, are wind pollinated. Wheat, corn, rice, radishes. Everybody relies on radishes, right? Beets, beans, peas, all of those are wind pollinated. We don't need bees for those. So guess what? Everything is overstated on the importance of bees to our survival. But doesn't mean that we shouldn't protect them. But we should protect them. But they aren't as important as you might think. And the beekeepers are dealing with colony collapse disorder. I'm sure you've heard that term before, right? CCD. Um, and that's because there's a global decline in honeybee populations. And usually honeybees will forage about 3 kilometers, 1.8 miles away from their hive. They often reach into urban areas where maybe we do a lot of mosquito control. But they can also be exposed to a lot of different chemicals in the environment. Do you know of any homeowners that apply pesticides on their own? Do you know of any homeowners that have those automatic misting systems out in their backyard? Yeah, they're all putting out pesticides that maybe have adverse effects on bees, because what happens if you lose electricity for a little bit with one of those automatic misting systems that's supposed to apply the pesticide after dark? Yeah, you have a timer, the timer is changed, and so consequently it may spray during the day. And so not everything is going to be from a mosquito control district. But colony collapse disorder is actually a combination of stresses, most probably a combination of stresses on the bee hive. And some of those stresses would be there's only a few different ways that a beekeeper gets queens. They buy those from commercial sources and they put them in their hives. And especially here in Florida, where we have Africanized bees, they have to re-queen their hives with commercially produced bees that are coming from a very standard genetic source. We have parasites and diseases of bees, malnutrition. Do you think hauling them on a semi-trailer from California to Florida is a little bit of a stress on a bee hive? Yeah, so when you put all of those things together, electromagnetic radiation can affect them, and of course pesticides. And everybody hones in on the pesticide component because it's something that they see. All of these other things are things that they don't see, but it's actually a combination of all of those stresses that are going to perhaps result in colony collapse disorder. And then when you look at what we do, we know that insecticides are an important tool for mosquito control. It's not the only tool that you use, but it is an important tool. And we know that it can have detrimental effects on pollinators. And when someone does something wrong, that is probably going to be on the front page of the newspaper, or probably filmed and put on the web and widely disseminated. And you put out aerosol treatments, you put out barrier treatments, and you take that thermal fog there. That they did a lot of that down in Miami with Zika. It's a very visual kind of mosquito control that people say, well, that's going to be bad for our pollinators, right? Probably not going to affect the pollinators much. Then you have the barrier treatments that are put out with backpack mist blowers. You have the ULV that's mounted on the backs of trucks, and you even have airplanes flying over. And I was contacted back when we had Zika back in 2016 by people that didn't want to be sprayed with dibrome down there, even though we had an epidemic of mosquito-borne disease going on down there, and we had congenital babies with congenital Zika as a result of that mosquito transmission of the virus. So I'm going to talk about two different experiments that we did. And one was the toxicity of insecticides used for mosquito control. And what we were looking at was the direct effects of applying the insecticides to the mosquitoes. We used both the honeybee and the mosquitoes done in exactly the same way. We published that in the Journal of the Mosquito Control Association, Florida Mosquito Control Association, back in 2019. Hussein Sanchez Arroyo was a senior author. He is a professor at the postgraduate university in Mexico. Uh, he got his PhD with me and came back for 2 years to be able to do this work, and he did a very nice job with it. And then one other study that I'm going to talk about is the field evaluation of aerial ULV treatments on mosquitoes and honeybees that we did in Greece. And it was something that when we finished that particular work, I was told, don't ever do that again. We actually took hives and we flew the insecticide on with helicopters and reported on that work. So that was published in the Journal of Medical Entomology. So all of this work that I'm going to show you has been published and is widely available to science. So let's see what you believe about this, get you to come up with a hypothesis. And there are actually 3 hypotheses. Insecticides are more toxic to honeybees than to mosquitoes. Insecticides are more toxic to mosquitoes than honeybees. Or 3, insecticides are equally toxic to bees and honeybees. So you have those 3 options. How many of you vote for B? How many of you vote for A? How many of you vote for C? Okay, so there you go. We're all over the ballpark on this as far as people's belief. Can you believe that after all this time, we don't, nobody has really told you what they found. So what we did was we did the lab procedure where we could actually drop the insecticide onto here honeybees and put a known amount of insecticide onto honeybees. We used different products that are available to you for mosquito control: chlorpyrifos, permethrin, deltamethrin, prelethrin, phenothrin, bifenthrin, and we dropped all of those onto bees and mosquitoes. We applied it directly to their thorax, and then we would rate the mortality at 24 hours and then find out the lethal concentration for 50% of the population, which is a standard way of doing toxicology work, right? And actually, what's interesting about this, take a look here. You see this number here? A lot of people don't know what that means. Milligrams per kilogram is the way that the way EPA decides how toxic a material is to you. In other words, the toxicity to humans. They use a rat and they do milligrams per kilogram of body weight. The lower amount of product that it takes to kill a rat, the more toxic the product is, right? The less it takes to kill, the more toxic it is. So that number is the reverse of what you would normally think that a high number would be good. No, or a high number would be bad. In this case, a low number is bad. And that's the same as what we say with insects, which is microgram per gram of body weight. So I'm going to present everything in milligrams per kilogram for you to look at. And so, for instance, when we did chlorpyrifos, for rats, that's 270 milligrams per kilogram of body weight. Honeybees is about 3, and a mosquito is 0.113. So if we want to say how toxic is the product to mosquitoes as opposed to humans or rats, we can say that it's about 2,400 times more toxic to mosquitoes than to humans. Do you have a safety factor built in there for yourself? Yeah, that's one of the reasons why these products are registered, is there's a differential toxicity. And if you want to say, is it more toxic to mosquitoes than bees? It's about 29, chlorpyrifos is about 29 times more toxic to mosquitoes than to bees. So if you chose B, you were right for this one, right? Okay, so phenothrin. about 12,000 times more toxic to mosquitoes than to humans. Amazing the safety factor that there is there with that particular product. And it's 11 times more toxic to mosquitoes than to bees. Is that what the beekeepers would tell you? No, the beekeepers wouldn't tell you that. Let's take a look at permethrin, which is another one of these products. The 20,000 times more toxic to mosquitoes than to humans. These numbers are unbelievable, aren't they, when you put them in those terms? And 4 times more toxic to mosquitoes than bees. Now, guess what? They don't all work out that way. Here is bifenthrin is about 4,000 times more toxic to mosquitoes than to humans, and 3 times more toxic to mosquitoes than bees. Are you seeing a trend here? But it's getting closer and closer. This one is 102 times more toxic to mosquitoes than humans, and about 7.5 times more toxic to bees than mosquitoes. So this one reversed. And then if we take a look at deltamethrin, it's 4 times more toxic to bees than mosquitoes. So if we were dealing with what was real on that first choice, deltamethrin and permethrin are insecticides that are more toxic to honeybees than mosquitoes. And chlorpyrifos, permethrin, phenolphthalein, and bifenthrin are more toxic to mosquitoes than honeybees. So you couldn't get this wrong unless you chose this one, which is they're equally toxic. None of them were equally toxic to bees and mosquitoes. So isn't that an interesting story? But guess what? It doesn't end there. There are other things that are done. And I wanted to put this on the Hodge and Sterner scale, which is what EPA uses to say how toxic is a material for humans or for any life form. And the toxicity rating is 1 would be extremely toxic, which would be less than 1 milligram per kilogram oral or less than 5 dermal. Since we were putting this on topically with the insects, I said, let's go with this dermal LD-50 of less than 5. Highly toxic would be less than 50. So you're probably going to have a signal word of what for a highly toxic material on the label. Caution, danger, warning. Warning, danger. So danger would be on this one, less than 50. Then 50 to 500, 500 to 5,000, practically non-toxic, relatively harmless. So if I take a look at where these things fall, is as insecticides, these things are designed to kill insects. And they're extremely toxic to insects, regardless of whether it's a mosquito or a honeybee, right? And we have chlorpyrifos, phenolphthalein, and permethrin. All 3 fall in that category. From the standpoint of humans, chlorpyrifos is moderately toxic. And for permethrin and phenolphthalein, for humans, it comes in the slightly toxic category. So does that make sense? Yeah, even though we have a differential there, you're saying that these between bees and mosquitoes, they're still all in the extremely toxic range. Interesting, isn't it? Okay, and then for the other insecticides, guess what? We stay there where all of these insecticides are extremely toxic to both bees and honeybees. However, for rats, moderately toxic for bifenthrin and slightly toxic for permethrin and practically non-toxic for deltamethrin. So you wonder why deltamethrin is so popular? you have a good safety factor there in being able to use that product effectively for mosquito control without affecting people. However, what I've just gone through doesn't matter because size matters. Did you realize that? Size matters. And there's a difference between the size of honeybees and the size of mosquitoes, right? So I was saying before that toxicity, the way toxicologists do their work is they say it's so many milligrams per kilogram of body weight or micrograms per gram of weight. Well, these weigh a lot more than these. As a matter of fact, a bee is 80 times heavier than a mosquito. So if you take that into account, it's going to take more insecticide to kill a large person than a small person, right? It's going to take more insecticide to kill a bee than a mosquito because their size has to be factored into it. And if we take a look at factoring size into it, every one of the insecticides is more toxic to mosquitoes than to bees. And it goes up to like chlorpyrifos is like almost 2,400 times more toxic to mosquitoes than to bees. And even permethrin, which is the worst from the standpoint of the toxicology, is 11 times more toxic to mosquitoes. So then I asked the question, and have you all heard this, that when you put out the ULV droplets, that a 20 micron droplet is going to kill a mosquito, but not a bee? Is that real science or fake science? You think it's fake? I've heard it for so long. I mean, I heard it 45 years ago, 46, 47, 48 years ago when I was in the Navy. People told me that before I went to the University of Florida. So this 20 micron droplet, we say that it's going to kill a mosquito and not a honeybee, right? So do you agree that that is real or that is fake? Let's vote for real. Is that real? You don't think it's real? How about fake? Everybody on the fake? How many of you don't care? You never thought about it, right? Because you're supposed to put out what the optimal droplet size for ULV ground treatments is what? About 20 microns. Should be about, what's that?
That's
Yeah, it's on the label. Okay, so if we take a look at the number of insects a 20 micron diameter ULV droplet can kill, it turns out for bees, it won't kill any. Actually, there's enough insecticide in chlorpyrifos in one of those droplets to kill 4 mosquitoes, 2 mosquitoes, 4 mosquitoes, and then it would take 50 droplets of bifenthrin and 5 droplets of permethrin to kill a mosquito. Yeah.
50 droplets kill a bee?
Would it kill a bee?
50 droplets?
No. 50 droplets? That's how many droplets it would take to kill a bee. So we're looking for permethrin at almost 11,000 droplets, and bifenthrin 115,000 droplets. And so those are the numbers of the droplets. I knew you were going to ask that question. You thought you had me, right? But it's unbelievable. Now, if you're looking at, let's say you're getting 2,200 droplets per centimeter squared, if the bees are out foraging, you're going to have that number of droplets impinge on a bee, right? Because it's larger and it's going to get those droplets on it. Whereas the mosquitoes, you don't need very many droplets to kill a mosquito. And, the recent work is that most of the droplets impinge on the wings and are then transported through the rest of the body. Did you know that? It's their wings moving that impinge on those droplets, and the hairs then hang up those droplets. The hairs on the wings hang up those droplets, and it moves down into the body and gets to the nervous system. So let's do real or fake again. See how good you are at this. Insecticides are more toxic to honeybees than mosquitoes. I have the answer here. Is that correct? Does that make sense? So that is a fake piece of science when you hear that. Insecticides are more toxic to mosquitoes than honeybees. I say that's real. And all of the insecticides, when you take into account the size of the honeybee and the toxicity of the products and everything, one of the things I'll go back to. You see this up here, this little stuff? I had never run into anybody that did that calculation. And so I went ahead and did it for this analysis here. It was no fun. I can tell you that. Okay, so all of the insecticides are more toxic to mosquitoes than honeybees. So the take-home message is, if you're going to get those 110,000 droplets onto a honeybee, where does it have to be?
Out and about.
It has to be out of the hive, and it has to be exposed to an area where those droplets are going to impinge on it. So basically, if you take a look at a 12-hour period of daylight and a 12-hour period of darkness, the bees are going to be actively foraging during daylight hours. And where do they go when the sun goes down? Yeah, so they go back in the hive, and that's when the mosquitoes are active and the bees are not, right? And that's when you're supposed to be doing your treatments. So basically, you have a lot of flexibility in what you can do as long as you do it after dark. And where we get into trouble is when things are not done, or let's say they contract someone to do the spraying that is not a professional in mosquito control like you guys are, right? So here's where things went wrong. This was a honeybee hive, group of hives in South Carolina, and you've probably all heard this story, right? And they hired someone who was not in mosquito control to do the aerial spraying, and they sprayed during the day as opposed to at night.
It was like visiting a cemetery, pure sadness. That's how one woman described seeing millions of dead honeybees in Dorchester County, South Carolina. And an aerial spray of a pesticide used to control mosquito populations is to blame.
I couldn't wrap my head around the fact that we spray poison from the sky.
Beekeepers in the area say their colonies dropped dead almost immediately after the spray was distributed on Sunday. A bee farm in one town lost about 2.5 million bees on the spot, and its co-owner says she's devastated.
All of my equipment is contaminated, my honey's contaminated, my comb is contaminated. I'm totally shut down.
The pesticide the county used is called Naled. Officials sprayed to kill mosquitoes that carry viruses like Zika and West Nile. Naled has been registered for use in the U.S. since 1959 and is primarily used to control adult mosquitoes. But it is toxic to other insects, birds, fish, and even humans. It's classified as a severe skin and eye irritant and is harmful when ingested or inhaled. Officials told WCIV this was the first time they have sprayed the pesticide from the air. The county normally sprays from the road. They say they gave residents plenty of warning with a newspaper announcement on August 26th and a Facebook post on August 27th. The county administrator did apologize for the incident Tuesday, telling the Charleston Post and Courier, "I am not pleased that so many bees were killed." But residents are looking for more than an apology. A bee activist group started a petition and a hashtag to end Naled spraying in the county. There are many chemical-free alternatives to pesticides that can help repel mosquitoes. To learn more about these methods and other information on pesticides, visit nospray.org. For Newsy, I'm Jay Struberg.
So do you think that hurt you guys? Yeah, almost every beekeeper knows that particular fact. which is if bees are out and foraging and you spray them, they die. And you should know that fact too, that you're going to get that 110,000 particles of insecticide onto bees if they're out and active. And that's where communication with the beekeepers is helpful, but not essential if you're doing the treatments at the correct time of day. If you're putting it out when the bees are in the hive, you should have no effect. You believe that? Okay, so let's see how well you believe it. Honeybee hives will survive properly applied aerial ULV treatments. Or honeybees will be killed by properly applied ULV treatments. Everybody goes with A? No dissension there, right?
In the middle.
Are you completely sure?
I'm in the middle.
You're in the middle.
I'm in the middle.
You're in the middle. Okay, well, we decided to take that one on and do that in Greece. And it turns out that in Greece, they have a very interesting situation. This is Thessaloniki, Greece. Have you heard of Thessalonians in the Bible? That's where Thessalonians live, Thessaloniki. I didn't know that before I went there. And what's very interesting, you think about rice production being in Asia. Well, they have 50,000 acres of rice fields. And also around the Axios River, they have 23,000 acres of natural wetlands. So how would you like to control mosquitoes when the prevailing winds are to blow these mosquitoes into a city of about 3 million people? So they have something very similar to like the Everglades in Miami or Naples, right? Where they're producing large numbers of mosquitoes here, and then they end up blowing those mosquitoes into town. And so I had a student who was Alex Pascapoulou, who came into my lab as a freshman and stayed on for her master's and her PhD, and she actually did her PhD work on this particular situation because they had no adulticides registered for use in Greece. As a matter of fact, the European Union had outlawed aerial spraying for mosquitoes. Yeah, they do, and they aren't allowed to apply any oils for mosquito control. So for instance, dibrome that would be diluted in oil could not be used there because it's diluted in oil. And most of the formulations that we had at the time were diluted in oil. And as a matter of fact, this was Mark Latham's ankle. If you know Mark Latham from Manatee County, he was stepping out of a pickup truck when we took this picture over there in Greece. And do you think they have a slight mosquito problem? Before his foot hit the ground, that's just after his foot hit the ground, that's how many mosquitoes were after him. Maybe he didn't wash his feet that morning. I don't know. So this was 2010 when we were doing this work and getting everything up and running. And it just so happened that Alex, who was a PhD student at the time, her father owned the largest aerial spray company in Europe. And so he bought a helicopter for her research, and he hung on it an electric atomizer, which nobody had done before. And when he first turned it on, it shut the helicopter down. And so they had to, it took about 6 months for him to work out that particular problem on how to turn on the sprayer and not get the helicopter to fall out of the air. In addition, we had the GPS and real-time weather probe that fed into a spray fate model that tells the pilot where to fly. That's quite common these days here. Back then, it was not common to have that occur. And so basically, she was using, because they couldn't apply oil-based compounds any place in Europe, we were using water-based, which was aquakeothrine, which now is registered in the US as Deltagard. Are you using that product? Some of you, if not all of you, are familiar with that and use that. And we applied that dose at the same rate that WHO says it should have been applied at. We had 2 treated areas and a control area that did not get treated. And so we have that untreated area versus the control area. So this is what one of the plots looked like. And these are cages of mosquitoes that were put out through the plots. We had no idea whether the spray fate model would work for water-based products because it was developed for oil-based products, right? So we had to confirm that we would get kill in the plots when he flew the correct pattern that the spray fate model told him to. And what we saw was between 60 and 80% mortality of caged mosquitoes. And if you've done mosquito cage trials, you know that a lot of the insecticide impinges on the mesh as opposed to the mosquitoes. So you almost never get 100% mortality. But we got pretty good mortality through the plots. But one other thing that we did was right in the middle of those plots, we put 5 beehives. And people told us, don't ever do that again. You're not supposed to do that. I said, well, why not? We do it all the time when you're supposed to spray, right? You have bees out there somewhere that you're probably spraying, so why shouldn't we do it? So we put those beehives out, and this was what it looked like during the nighttime spraying, right before spraying. That's one of the technicians that we had out there. Is that a few mosquitoes? There are also other things flying here too, like a grasshopper or something, but these are all mosquitoes. These are all mosquitoes that are going after him. This is 15 minutes after treatment. He's still eating. Now, if you take a look, that's quite a difference, isn't it? This is Alex out there, and if you see, there are 4 mosquitoes on her head. And there are more coming in for a meal. And this is 15 minutes after treatment. Do you think it worked?
Oh, yeah.
I'll tell you one of the things that we had problems with was this was done with GLP European style, which is good laboratory practice, which requires you to have someone who's not associated with the research at all to come in and observe to make sure everything was done according to the protocol. So we had a real problem because the people that were brought in to observe this knew nothing about flying insecticide on because it was outlawed in Europe. So they were going, he's applying it over there, and the plots are over there. So that's wrong. And we were going, well, the spray fate model says there's a 5.2 mile per hour wind, a kilometer per hour wind that's going to take the stuff over to that plot. And just the process of telling them that this was the correct thing to do was very difficult. People don't realize that the insecticide is going to travel almost a mile from where it's put out up in the air down to where you want the insecticide to land, right? So just from that, do you think we did it right? Yes. Yeah, we did it right. And as a matter of fact, this is a CDC light trap catch before and after spraying. So this is a CDC light trap catch where we were getting about 90,000 mosquitoes in a night. How would you like to go through all of those, Terrell-Lynn? No? I don't think anybody would, right? Trying to figure out which ones are there, especially if they're in Europe. They aren't the same ones that we have here. And then to throw on top of this, I just put this in just for fun, is that in 2010, they had a West Nile virus they had West Nile virus show up in Greece, which was the first time it had ever shown up in Greece. And they were having economic difficulties back then. And on July 16th, they had their first case of West Nile virus. On July 15th, they had no more money left to be able to continue larviciding, so they discontinued larviciding. And what happened when they discontinued larviciding? Those are the cases that appeared, and these are in urban and agricultural areas. So the dark green is agriculture, which would be the rice fields, the villages associated with the rice fields. And this is when the Prime Minister of Greece stepped in and said, we had all the data to show that this would work and that we could control the epidemic with ULV treatments by air. So they put on the first ULV treatments, and right after that, then the disease went away. When she did her dissertation for her committee, Roxanne Rutledge, who is with CDC now, said, people have worked their whole lives to be able to show that you can actually manage a disease with mosquito control. And they've never been able to do it. This is the best documentation she's ever seen that that occurred. However, what happened to the bees? Let's get back to the bees, right? That's what we're supposed to talk about, not whether you can manage it with ULV sprays. But okay, did I mention that the Prime Minister of Greece had to step in and declare those registered because they have so much bureaucracy there? He just said, the heck with that, we have people dying. And they had like 40 people die before we got the approval to be able to spray. and it was a very virulent strain. We found out it was the most virulent strain that had occurred in Europe that happened to occur there in Greece. Well, we had those 15 hives, 5 hives in the untreated area, 10 in the treated areas, and we monitored each hive for dead bees, black shiny bees, which shows that they were affected by the insecticide, bee behavior, population, weight, brood, honey production, and pollen characterization. You think that's good enough? I think it's good enough for me anyway. They went ahead and did that. We did that in conjunction with some of the apiculturists there at the University of Thessaloniki. And this was like one of the hives. And there was a pollen trap applied to be able to capture pollen, see whether the bees were foraging normally or not. And also any dead bees would be kicked out onto that tray there, and then you could count the dead bees. This is what the mortality, and we saw no black shiny bees, and this is bee mortality in the treated and the control areas, and that's when the treatments went on. Is there any correlation between the treatments and dead bees? And this is about as bad a situation as you can get, because there those bees were right in the middle of the sprayed area, and we documented the mosquitoes were being killed. And we weren't able to document that any of the treatments did anything to the bee population. As a matter of fact, natural bee mortality can go up to almost 20% mortality during that period of time, and we never achieved that with either the treated or the control area. Who would have thought, huh? Who would have thought, especially if you read or you listen to that clip ahead of this one, all of those dead bees and how bad mosquito spraying was. There were no shiny bees ever observed, which means that they didn't get a sublethal dose and then started shedding their CD and appeared shiny because of them being sick. And if we take a look at the bees, brood, and weight of honey produced, this is the weight of honey in the control area. And if you see something, we had more honey produced in the treated areas than in the control areas. We had a little bit of decrease in the brood, And as far as adult bees, we had more adult bees in the treated area. Do you think there were any adverse effects? I didn't see any adverse effects, did you? No. As a matter of fact, if anything, we were dealing with 5 to 7 kilograms of honey being produced during the trial, and that was all very good. And then with the pollen that was collected, we actually increased the amount of pollen collected, and you can determine the species of plant from the pollen that falls out. And like 90% of what they were feeding on was rice, which bees aren't supposed to go to rice flowers. If you remember, that's one of the ones that isn't pollinated naturally by bees. But guess what? When you put them when you put your treatments right in your bee hives right in the middle of a rice field, guess what they're going to do? They're going to forage for rice. But there is increased foraging in the bees in the areas that we treated. And the bees actually were doing better. Now, the only explanation that anyone ever gave me that made sense was that sometimes when you have a lot of bees, the old bees and the sick bees are going to be on the outside of the hive as opposed to on the inside. And the mosquito spraying probably increased the production because it killed off all of the weak and old bees that should be killed off. Since I'm retired, I guess I should be put to pasture, right? Put 6 feet under. But that's the only explanation that I've ever heard of why that would happen. And I don't know if it makes any sense that when you have too many bees in a hive, they're going to make the sick ones sit outside and get killed with the insecticide. So if we take a look at what we've looked at today, we've gone through a lot of different stuff. One is that with this particular study, we had about a 90% reduction in the mosquito population and controlled an outbreak of West Nile virus. As far as non-target mortalities, the bees were unaffected by those applications, and no significant bee mortality was observed. And the beehives exposed to ULV treatments performed as well as those that did not have the treatment. So, real or fake news? What do you think? Honeybees will survive aerial ULV treatments. Okay, so I got you converted. You're converted now, right? You're converted now. But guess what? They have to be properly applied. If you put them out when the bees are out there, you're going to kill them, right? And the hives are going to be killed off with those aerial treatments. That's fake news. And you can definitively say that that is fake. And as a matter of fact, we had the Prevent and Protect program from UF that was put out. These posters are available to you. I think you can print them off online. Do you have those here?
Yeah, I can print them.
Okay, yeah, you can print them. You can print them. And basically, what they say in here is some things that how beekeepers can help bees is to make sure that the treatments are applied when? Dawn or dusk, when the bees are not foraging, so that they're protected from the insecticide. Because even though it takes a large number of droplets to kill them, guess what? You still can if you put it on at the wrong time of day. It's a very simple story, right? But pretty complex when you try to answer it and separate what is fact and what is fiction. So, did we answer that? Chemical pesticides are killing the world's honeybees. That sounds pretty fake, doesn't it? Yeah. Although you can do it if you do your job wrong. So that your job is to do it correctly. And of course, I'm not a cat lover. So if you try to kill a cat with those insecticides, guess what? you can't because they got 9 lives and they're going to live no matter what you do to them, right? So, did you have any questions? Yeah.
So you said you monitored the behavior. What behavior? Was that just the pollen collection?
Okay, that was a pollen collection.
Oh, okay.
Yeah.
All right.
Yeah, so they were behaving normally because they were out there foraging and collecting pollen.
What time of year was it in Greece? Like, what was the season?
The season was late summer.
Late summer. Okay. I figured with all the mosquitoes, but good to ask. Just
Yeah,
who knows what
late
it's like in
summer.
winter?
Yeah. Actually, it's interesting that they had a lot of Culex quakes
Really?
out there breeding in those particular areas, and they're primarily feeding on cattle that are interspersed in amongst the rice
I have
fields. Yeah.
What was the larvicide they were using and why did they stop?
But
If you know.
they were using Dimilin,
Okay.
and they originally were using a better compound, but they were the European Union outlawed that, and then they went to Dimilin applications, and they were applying that by air to the rice fields, and they had to stop that. What was very interesting for me was when we finished the project, Greece asked me to come over and receive some awards from the municipalities over there. And so I told Alex, I said, why don't you just receive the awards because you did all the work? I was here. And she said, you don't understand, I'm a woman. They're requiring you to come over and receive the award. So I went over there, and it was really kind of interesting. I spent a week over there, and they had a banquet for me at each one of the communities in amongst the rice fields. But they also had a big award ceremony where the mayor of Thessaloniki and all of the dignitaries were there. And the U.S. Embassy decided they wanted to get involved with this, and that the consul general had to introduce me in person, which meant that they needed bomb-sniffing dogs and simultaneous translation and all of that for this thing, for me to receive this award over there. And I asked Alex, I said, do you know any of these people? She said, no, I've seen them on TV. And I don't know any of them. But anyway, it was a big deal back then when we did that because of us taking care of the West Nile virus epidemic for them. And it was interesting that I didn't do anything. And I got a nice plaque out of it. Okay, well, thank you. And thank you, Carolyn, for putting the program together today.